Hi, I'm Andy, and this is a video about dependency injection frameworks, and in particular why I try to avoid them. I'm trying to be nice in this video because dependency injection frameworks have been written by people who obviously needed them, very smart people. I'm going to try not to be mean to them, but I'm going to try and explain what I see as some of the downsides of using them that I've found in the code that I'm working on. This talk has got a fair bit of Java in it, and I think dependency injection frameworks are most commonly used in Java, but I think the concepts are relevant to other languages if you attempted to use dependency injection frameworks in them. Also, the dependency injection framework that I've got the most experience with is Juice. I'm sure that Juice has upsides and downsides compared with other ones. This is not an attack on Juice, this is an expression of some of the reasons why I avoid using dependency injection frameworks. It's clear that Juice and other dependency injection frameworks, as I said, written by clever people to solve real problems. I want to try and suggest to you that maybe some of those problems could be solved in different ways. So I'm going to try and make that argument to you. So we'll start off by just talking about what dependency injection is, and then we'll talk about what a dependency injection framework is, which is a different thing, related obviously. I'll outline some reasons why you might want to use them, some reasons why you might want to avoid them. I haven't put it in the contents page, but they'll then be followed by a slight rant, and then we'll sum up at the end. So strap in. First of all, what is dependency injection? Well, dependency injection is an idea from fairly early in object-oriented programming that's still really important. The idea is not creating the stuff that you use to do your job, but getting someone to give them to you. And I mean, you could take that to the extreme and it would be silly, but it's often a really good idea, especially to support testing. It wasn't originally designed necessarily to support testing, but that is a critical part of why it's so important, I think. What is a dependency injection framework? Well, hold your horses, we'll get onto that. Let's do a little bit more about what dependency injection is. So let's start off by talking about what code used to look like before we learn a bit about how to write code. In the times where most code was procedural, as we call it, we essentially just wrote down like a list of instructions of what we wanted to do in the order that we thought of them. So this is a bit of Java code, but it's kind of demonstrative of that style of coding. So we make in the main method, we make an instance of a class called what day is it. We call a method which prints out the day, and that's our whole program. You can see the class in the bottom half. It has this method. The constructor doesn't do anything, and then it has a method called print day. What print day does is creates a date-time formatter object, and then uses that formatter to format now in that format that we've given it. The formatter just prints out the day of the week, and then it uses system.out.println to actually print out the answer. So this is written in sort of relatively modern Java, or not completely ancient Java, but it's intended to illustrate a style from a long time ago, procedural programming, where you just wrote a list of instructions: do this, do this, do this, and it's not really the object-oriented style that we would recognize, and that's really because the object-oriented style that we would probably recognize you naturally end up using dependency injection. So what is dependency injection? Well, let's talk about what the dependencies of print day are. So here's that code. Have a look at that and tell me what you think the dependencies of this piece of code are. Thought of that? Given your answer? Well, here's one. So looking for the time now. So instant.now just returns the time now. It's actually an instance of the instant class, which represents whatever the system clock says the time is. That's the dependency of this code. Also, system.out. So the fact that this program will print directly to the console could make it a bit awkward to work with if you changed your mind about where you wanted it to print later. So we definitely say that system.out, and that kind of static object that we're calling the println method on, is a dependency of this code. What about formatter? Is formatter a dependency of this code or not? Well, it's a good question. And I think it helps to illustrate some of the ideas behind when I think dependency injection is a useful or not useful thing to do. So my key question, and again, dependency injection was not invented initially to support testing, but my key question when I ask, do I consider this a dependency that I should inject, is do I need to inject that dependency to be able to unit test it? So originally, dependency injection was invented to provide reusable code, but the particular type of reuse of code that I'm interested in, because I think it gives us good code if we think about it, is can I reuse this class in a unit test? As in, can I test this class? But it's a type of code reuse, right? Sometimes the only two uses we put our code to are unit test and production use. But that's good enough, and that's one of the reasons why test-driven development is so great, because it makes us do two uses instead of one. Well, the answer is yes, I can unit test without injecting formatter. So here is a unit test which works on a different class. So the original class was called What Day Is It? I think. The class that we're testing here is called What Day Testable. It's very similar, but it's been modified to allow us to write a unit test. And the way it's been modified is that I'm injecting its dependencies. So you can see about halfway down the page we create an instant of What Day Testable, and into its constructor we pass its two dependencies, a print stream and a clock. And then we call the print day method on it, and then we assert that the answer it gave was Thursday. Now, if we'd used the original class, we wouldn't have been able to test that the print stream ended up with a Thursday in it, because depending on the day, it would have produced a different day of the week. Depending on what day you ran that unit test, it would have produced a different day of the week, because it was using instant.now. And also, it would print that value straight out to the console, which is no use. So what we've done is those two dependencies that I identified, instant.now and system.out, we have replaced in this class with two things that can be passed in, and therefore in our unit test we're able to pass in things that are easier to test than printing to the real console. So we made a print stream, which is based on a byte array output stream, and we're passing that in to use instead of system.out. System.out is actually an instance of print stream, so we've kind of kept the same similar looking code inside What Day Testable to what we had originally. With the clock we had to do something slightly different, because we're using instant.now, which returns an instant. It's a little bit difficult to pass an instant in. The best thing to do, or the way that you're supposed to do this with clock stuff, is pass in an instance of clock, and then clock has a method on it that can get you now, but it's now according to that clock instead of now according to the global system. So what we've done here is we've made an instance of clock which always returns the exact same time, no matter when you ask, so that whenever we run our unit test, even if we run it on a Friday, heaven forbid, it will still return this exact date that you can see in the top middle of the code, and that is a Thursday, I happen to know, so I can run this unit test on a Friday. The answer will still be Thursday because the clock says it's Thursday. Yes, that is quite a lot of code just to get a clock that's fixed to a particular time. As usual, blame Java. If anyone knows a way of writing less code to get that clock, I'd be really interested. Feels like a lot. So this is a unit test which tests this class, which is very similar to the class we looked at, except the dependencies have been injected instead of being hard-coded inside the class. So that's what dependency injection is. So here's the class. It takes in a print stream and a clock, as I said. And instead of calling system.out.println, it calls printstream.println. And instead of using instant.now, it uses instant.now at passing in an argument. And that argument is what clock to ask for now. Instead of using the default is to use the system clock if you don't provide that clock argument. Because we've provided a clock argument, instant.now uses that clock to figure out what it's going to consider now and gives you back that instant. By the way, don't you find it dirty that instant.now with no arguments touches like the global system, and instant.now with just one argument suddenly is a really clean and testable function? Wouldn't it be nice if those things were called out, drawn out into very separate things, so we couldn't accidentally confuse them and use a global clock when in a situation where we don't want to? I would like that. I would like it if there were instant.now. I would like it if touching the global clock was in a totally separate class or something. But I would like a lot of things, wouldn't I? Okay, anyway, so that's dependency injection. This whatday testable is our dependency injectable version of the whatday class. Notice that we haven't injected formatter, as I mentioned. We can perfectly well unit test this code without injecting formatter, as long as we're okay with our unit tests only being in the locale and time zone that are hard-coded in the test. So if our next unit test is going to be actually testing that we can answer the question, what day is it, in a different locale or for a different time zone, then yep, you'd better inject your formatter as well. And then your unit test can say, if I have this formatter and it's this time, then I print so-and-so to this print stream. But let the tests drive you, and let the requirements for your code, obviously, drive your tests. Maybe not, obviously. So here's a diagram explaining how I think about dependency injection. Don't worry, we'll get onto dependency injection frameworks soon, and we'll probably get more ranty and less reasonable. So on the left, we have a classic piece of code where we have a main method that creates an instance of a class. And in order to do its job, that class creates instances of other classes, and those create instances of other classes. Often things create instances of things in their constructor. Often things have, say, a default constructor which creates instances of things, or you can pass in another one. Again, I don't like that mixing. But yeah, so on the left you have the kind of do some stuff code. Create what you need, use it. On the right we have the idea of dependency injection, where your main method creates some things and passes them in to your class, and your class uses the things that were passed into it instead of creating them itself. So on the left you can go down an unlimited depth of layers of things depending on things, depending on things, depending on things, and a lot of that code is untestable, unreusable, because it's hard-coded, like the details of what it does and what it operates on, for example, system.out, are hard-coded in there, whereas on the right, if you want it to operate on a different print stream instead of system.out, well, you just create it and pass it in, like we did in our test. So you're kind of limited to those three layers of classes that use interfaces. So the three layers are the main method, the concrete classes, and the interfaces that those concrete classes implement and use. Whereas on the left, there could be any depth of dependencies. So it's a flatter structure. Potentially added a little bit of complexity in order to have that structure. We potentially added interfaces where previously we only had to think about the concrete classes. But it can be worth it if you want your code to be reusable, and especially if you want your code to be testable, which means checking things like what does it print to the console, which you can't do, well, it can't easily do by actually checking what it prints to the console. Instead, you can pass in a different print stream for it to print to. With me so far? So, what is a dependency injection framework? Well, going back to the same example we were just using, this is what our main method looks like when we are injecting dependencies manually. So we create a print stream, we create a clock. In this case, these are kind of the same print stream and clock from our very, very original example, but this time we're explicitly creating them and passing them in, or getting references to them and passing them in. So that's what it looks like when we're manually injecting dependencies. But you might think that that's an awful lot of work, creating those two objects and passing them in, and you would like someone to do that work for you. So you would use a dependency injection framework like Juice, which is obviously much, much easier. Right? So here we've created an injector. So this is Juice as an example, but a different dependency injection framework would have some way of doing something similar. So you create an injector, and then instead of creating an instance of your class yourself, we create an instance of a class by using the injector. And in the case of Juice, we call get instance, say what class we would like an instance of. And because we've set up our injector with the ability to provide instances of things when we ask for them, when we say get instance, what that get instance code actually does is goes and finds the things you need in order to construct your whatDayJuice class, and provides them to that class as constructor arguments or similar. And then what we get back from getInstance is actually an instance of whatDayJuice, so we can call printDay on it. So it's doing the same job as the line that created the object and then called printDay on the previous slide. So most of the slide is taken up with this configure method and the abstract module stuff. So basically, that's us telling Juice when someone wants a print stream, give them system.out, or when someone wants a clock, give them the system UTC clock. And there are more sophisticated things you can do rather than just saying give them this instance. You can say create a new instance, or use a provider object to create an instance, or more sophisticated things even than that. And some of those things, when you're creating stuff that's going to get configured in like this, actually to create one of those objects, you might need to have some other objects that have already been put into this namespace first. So Juice will handle, or the dependency injection framework generally will handle constructing all the things that you need in order to construct the thing that you need in order to pass it into our real class that we're really asking for. So it will kind of go and find what's needed by all the classes and those classes and those classes, and construct them for you. So you can tell there was a hint of sarcasm when I was saying that this was somehow simpler than the previous thing. The previous thing looks like this, and then we can, the idea is you do less work constructing objects by writing code like this, but obviously it's more code. But potentially that code manages all the interdependencies between objects without you having to think too much about them. So a dependency injection framework in my head looks a bit like this. So you have a main method that instead of constructing an instance of my class, it kind of vaguely asks for, please could I have something that implements this interface or is of this type. And the class itself uses stuff via interfaces very similarly to the right-hand side of the previous diagram, the dependency injection part. But instead of us explicitly constructing those in the main method, we ask the dependency injection framework, which I've illustrated here as a green magic cloud of power, and that will do the constructing. So when we ask, in order for me to work properly, I'm going to need a print stream. Could you get me one of those, please? Then the magic cloud of power knows how to make that stuff for us. Anyone who's heard any of my videos before will know that when I use the word magic, I often mean bad. And hopefully I'll get across why I think it's bad to do magic in this way as we keep going. So, as I said before, if you use a dependency injection framework, you don't have to write all of this straightforward standard Java code that's only 3 lines. Instead, you can write all of this crazy abstract module weirdness, passing in passing class objects into bind methods and stuff like that, and magically you'll get an instance of whatDayJuice without having to construct it yourself. So here are some reasons why you might want to use dependency injection frameworks. Well, I mean, the initial kind of main argument for it is you don't have to write code that constructs objects. You don't have to spend a huge amount of time constructing all your objects in the right order, please note, in your main method or in methods called by your main method. You don't have to think about even what the right order is. You can just use, if all your objects use the logging framework, well then you just say, oh, please can I have the logging framework? And the dependency injection framework will build you an instance of your logger or your logging framework and make sure that it gets passed in at the right time. So you don't have to think about the fact that, oh, actually the logging framework needs to have done its logging configuration code before it can be constructed, but then the configuration code needs to have a logging framework because it needs to log if everything went wrong. You don't have to think about any of that stuff. You just ask in the configuration code, you ask for the logger, and hopefully it'll turn up. Other reasons why you might end up using dependency injection frameworks. Number one, because you're using some kind of wider application framework that forces you to use it. In which case, if you agree with my advice in this video, hopefully there's ways you can minimize the usage of the dependency injection framework, keep it to somewhere near the main method, and then do the rest by passing arguments into functions, which is my preferred way. Also, your boss might think dependency injection frameworks sound cool and everyone's using them. Probably not a good reason. So here are some reasons to avoid dependency injection frameworks. Here's a big one for me. It prevents me from searching for normal code patterns that I would search for in Java. So for example, if I want to find, I'm looking at the whatDay juice class, I want to find out, okay, that gets passed something in that that it's not quite working the way I want it to, or it's not being passed in the right thing. What I want to do is search for everyone who creates a new instance of whatDay juice, so I can see who got it wrong or how it's, where the bug might be. So if I search for new whatDay juice, I won't find any mention of that at all in my code, because actually it was created using this getInstance method. But also, even if I find the getInstance method, that doesn't explain to me how its dependencies ended up being given to it. So it's not just a matter of, I need to stop searching for new whatDay juice and start searching for getInstance whatDay juice. It's actually that once I get to that getInstance line, I actually still can't see what's being passed as arguments to its constructor. I have to delve deeper into the dependency injection framework and how it constructs things and where it gets dependencies from. So by the way, I've used an example of grepping for new whatDay juice here, but the same applies to your IDE. If you search for everyone who calls the constructor, you won't find anyone calling it, because that's done magically somewhere in the background in the dependency injection framework. Also, if you want to know who calls setters, if your dependency injection framework is able to call setters to provide objects that are used by a class, again, searching for who uses that setter will tell you, well, no one uses it. But actually, the dependency injection framework will kind of secretly use it. So that's a big thing for me. How do I figure out how this class got constructed? When I search for it, it looks like no one constructs it. Secondly, in general, it's harder to understand the code. So the top here are the simplest possible versions of injecting instances of classes into the dependency injection framework in Juice. And similar in other dependency injection frameworks, although sometimes you might get to write that code in XML. So this is the simplest example. There are much more complicated examples of how objects can get constructed. But even these simple examples are way more complicated and unfamiliar compared with just getting hold of system.out or creating a new instance of something yourself, like the new instance of clock that we created, although, that's a bad example because the instance of clock that we created was complicated. But yeah, you need to do that whether you were using dependency injection framework or not. So it's more complicated. You need to know a lot about your dependency injection framework before you understand what's going on. So in order for that to be, and that could be worth it, obviously the simplest possible program is one with no code in. So sometimes we have to write code, even more complicated code, to get some benefits. But if there were no benefits, I would prefer the bottom to the top. And I'm arguing that the benefits are marginal. And that, actually, what I'm arguing is that there are some downsides, big downsides. So next reason to avoid dependency injection frameworks, because, and this is a huge thing for me, it's action at a distance. So instead of creating an instance of a class and then passing it into the method that uses it, and then that gets passed into any other method or constructor that uses it, and so on and so on and so on. So you can always trace the chain of calls, function calls, method calls that pass in the object that you were using. A kind of fundamental reason for the existence of dependency injection frameworks is that you don't have to have that whole chain of stuff. But I really object to that because it's action at a distance. If you delete the line of code that creates the clock and injects it into the dependency injection framework's namespace, you won't find out about that because of a compile error. At least in Juice, there is at least one dependency injection framework that will actually tell you about that at compile time. But nevertheless, it will tell you about something that is quite a weird, subtle interaction that you have to understand that framework in order to understand. So yeah, I would always be thinking, if I'm looking at a class, I'm thinking, well, okay, so it uses a clock, it gets passed in the constructor, it gets passed in a setter. Where did it get that clock from? So I'll search for who constructs me or who calls the setter, and we're back to problem number 1. You can't find out. It's not coming by calling the constructor. It's coming by some magic happening in a dependency injection framework, and it's hard to link them up. Okay, next reason that I find dependency injection frameworks problematic. They're just global variables. So the namespace of the dependency injection framework, or the injector in Juice language, it's a global namespace. You dump everything in there, and then it pulls things out when it needs them in order to construct objects or to call their setters. Except most global namespaces with global variables in, at least the variables have names. But in most dependency injection frameworks, you generally get hold of objects not using a name, but using their type. Now, obviously, if it's a type like string, then there is often in these frameworks an ability to name those things so they don't get confused with each other. But that's like an optional extra. So most of the things in that namespace, it's in a global namespace. They don't even have names. It's you can't see where they're made, and they might not be there. Right, so it's not just a global namespace, it's a dynamically populated global namespace in a lot of these dependency injection frameworks, not all. So if you change your code, and by the way, I've done this, if you change your code so that the object is no longer there, it never gets put into that namespace, or maybe it gets put in too late or something like that, then at runtime, when you've deployed your code to production, yes, this has happened to me. When you've deployed your code to production and you try and run it, it's not there. So all my tests ran because in my tests I remembered to put the objects into the namespaces. But in the production code, I'd messed that up. That object wasn't getting created or was getting created too late. My code fell over when I tried to run it. They might not be there. It's global variables. They don't have names. They might not be there. Doesn't sound good. What else? Well, Juice specific. There are some ways of getting undefined behavior in Java, and a good one is if you make a field of an object final, and then you use reflection to modify that field, because final fields are never supposed to get modified, what the reference that they're referring to. But if you use reflection, you can actually modify what they're referring to, and in Java that's undefined behavior. So it might just give you a banana when you do that. It might launch rockets. It might give you the old instance that it was originally initialized with, which in this case is probably null, or it might give you the instance that that got modified with reflection. So in Juice, you shouldn't do it. You shouldn't put @inject onto a final field. But you can, and it'll compile and run. It just has undefined behavior. So it makes me wonder whether someone thought that C++ was getting a monopoly on having all the fun with undefined behavior. So maybe Java should have a bit too. So by the way, just as a practical tip, don't do that. So if you have a field with @inject on it because it's getting its dependencies injected by Juice or some other framework that works the same way, don't declare it final. It's undefined behavior. It might give you 2 bananas. Okay, another reason. It encourages you, or it can encourage you, to use singletons as a concept. And I thought we'd agreed that singletons were a bad idea and you shouldn't use them. There are some coding patterns that give you singletons, which, by the way, are global variables. But by giving us mechanisms for explicitly labeling things as singletons and having a published behavior of them being a global variable that's always accessible, we're kind of blessing that concept of singletons. Don't like it. Further, if you must have singletons, or at least only one instance of a class, why don't you just make that instance in your main method and pass it around, and then there'll only be one instance of it. What's magic about a singleton that means that you need special code for it? I won't labour that point. If you think singletons are really good, then you probably disagree. If you don't, well then I've probably already convinced you. This is another Juice-specific point. Something you can do in Juice, and possibly in other similar frameworks, is you can add an @inject annotation to a private field of an object. So what that means is, if you don't provide a constructor that initializes that private field, Juice will happily be able to construct that object and set the value of that private field. But no other code will be able to construct that object at all, because it has a private field that's not initialized by any constructor. So there's no constructor you can call which will be able to create that object with that field populated. So you end up with a situation where you can only make an instance of that object if you use the dependency injection framework to do it. So that means you end up with unit tests like this. And yes, I speak from painful experience. The very bottom bit of this code is me getting hold of an actual instance of my class, which here I've called what day juice no construct. The rest up to that point is all needed in the unit test, but all it's doing is allowing us, setting up an environment which allows us to create an instance of our class so that we can then do something in it with it to unit test it. So your unit test ends up with a whole load of code that looks like this. It makes me really sad. The readability of unit tests for me is absolutely key as to understanding what your code is doing and whether it makes sense and whether it's structured well. If your unit tests look like that, well then no one in your team is going to want to look at them because it makes your eyes bleed. You're going to be sad. You're not going to have no pride in your unit tests or the readability of your tests. And then so the rest of your tests are going to look like that as well. And then when someone tries to read it to figure out what your code does, good luck. Further on to this point, in general, dependency injection frameworks, which by the way often advertise that they're good for making testing easy. And I would agree that dependency injection makes testing possible, but dependency injection frameworks often end up making your tests have a whole load of code related to your dependency injection framework, not related to your class and what it actually does. Fills your tests with incomprehensible framework gubbins. The word framework may be a bit like the word magic that I used earlier. Frameworks, the word framework immediately makes me think, I'm not sure I want that. Framework gubbins is maybe why. Okay, so readable tests, really important. If you've got stuff about dependency injection framework in the test, that's noise taking away from actually just being able to read your test. Finally, and perhaps most deep philosophically, a potential reason to avoid dependency injection frameworks is that they hide the pain of having huge and painful dependency trees. As I was saying near the beginning, you can construct an instance of your object and it will just figure out, what depends on what, and then what of those dependencies depends on what, and it gets it right in the right order. Even potentially deals with dependency cycles, which, by the way, you shouldn't have. And it makes that go away. It magics it away. Except, of course, immediately when you try and test, it's no longer magicked away. You've got to deal with it. And obviously you write your test before you write production code, right? If you want to have good code, you do. So why were we doing this again? So my point is, actually, the pain of huge dependency trees is good pain. Pain can sometimes be a sign that something is wrong. If you have huge unmanageable dependency trees, That's your problem. So let's slip slightly more into rant mode. So let's look at some of the reasons to use dependency injection frameworks. So first of all, so you can write less code that constructs objects. So here's my response to that. If you're too lazy to write code like this, so this is a constructor which takes in the dependencies and then collects those dependencies and stores them in the class. And obviously you need fields, definitions of fields in your class for this to work. If you're too lazy to write this code, well, what do you think my answer is going to be? I'll give you one guess. My answer is going to be use Kotlin. Writing that code in Kotlin is one line and really easy to use. By the way, use Kotlin. Second reason to use them, you don't have to worry about complex interdependent objects. It'll all be done for you. I have a rant about this. So if you're too lazy to write this is code that creates some dependencies and passes them in to your class. My message to you, can you guess what it is? Not use Kotlin. My suggestion to you is that you need to drag and up. This is your job. You're not writing some dumb program, otherwise you wouldn't be thinking about these complex dependencies. Actually, as programmers, what we do is manage complexity. That's what we have to think about. That's what we're supposed to be good at, and that's what we're trying to get good at. Your dependencies are a huge part of the complexity that you're managing. Basically, if you just writing methods that just do stuff in a certain order, the level of complexity you can get to is low. I know methods can get long, but yeah, don't have them get long. So basically, the interactions between objects and which objects use which objects are an absolutely key part of the dependency that you're trying to manage. Your job is managing complexity. You can't just have a machine do it and expect it to do it well. Here's an analogy. A programmer who doesn't think about dependencies is like a farmer who doesn't think about irrigation. Potentially, that farmer might grow some things, or potentially they might not. It's core. It's part of what we do, really key part of what we do. So, if your dependencies are causing you pain, don't make the pain go away by waving your dependency injection framework at it. Listen to the pain. Figure out why your dependencies are going so crazy, and try and make it better. That pain was a sign that something was wrong. So, let's try and get a bit more practical about how you'd actually do that, rather than it just being me saying, oh, just don't do that. Well, so if your code looks like this, a main method that uses an A, that uses a B, that uses a C, that uses a D, don't kind of try and patch over the problem by sticking something in between A and B, and something in between B and C, and something in between C and D that kind of makes it look like it's not a chain like that. How about just making it not actually be a chain like that at all? So how about structuring your code maybe a bit like this? And this is more an idea that I'm playing with than some well thought out theory. How about a lot of your code is written like the bottom half of this diagram, A, B, C, D, E, where your classes are simple and don't have dependencies at all. Or maybe they have, like with C and D, maybe they have a bit of dependencies, but really not too much. So try and make your code completely self-contained, not depending on a whole load of other stuff getting passed into it. Obviously, in order for your code to do stuff, your classes are going to have to interact with each other. So I'm suggesting maybe try and write code that works with stuff like that in separate methods, which are hard to test, but not impossible, by the way, using dependency injection. Like the do stuff box or the main method in this diagram. Code that does stuff, it's going to need to get hold of objects and call methods on them and work and use them together. But try and structure as much of your code as possible, like the bottom half. Stuff that is stuff, maybe, or certainly stuff that has few dependencies and is not halfway down the chain like we saw in the previous slide, but just lives on its own. You can use it to do stuff. By the way, it's great unit testing classes like that. Really easy and fun. So let's try and get concrete with our example and how we might work a bit like that in our example. Obviously a simple example, but hopefully Principles still apply. So let's look back at our manually injected version of the whatDay class that takes in 2 dependencies and then uses them. So, I was holding this up as an example of good code, but actually it's an example of that first slide with the chain going down, 1, 2, 3, 4, 5. This class uses 2 other classes, and potentially it could be part of this long chain. So can we do better? Can we make whatDay testable more like one of those standalone classes at the bottom of the second diagram? Well, how about writing our code like this? So we still have a printDay method. The responsibility of that method is to say what day of the week a particular time is. So let's compare it with the previous version. So previously we passed in a print stream and a clock, and then we used printDay. PrintDay's job in that case was to find out what time it is using the clock, and then print the day of the week to that print stream. So here's our updated version. We pass in a time and we return what day of the week that time represents. Notice, by the way, we're still not injecting formatter as a dependency. We're passing in a time and we're returning a string. So we're not injecting any kind of print stream or anything like that at all. So I would argue this is more like that second diagram, and this is much more a standalone piece of code now that does just one job. But actually, our printDay's job, and by the way, we should probably rename printDay now, but printDay's job, it turns out, was not to print to a print stream the day of the week that it is today. PrintDay's job was to tell us what day of the week a certain time is. Right? That's a simpler job, and we've pushed the pain of what real life clock and what real life print stream are we going to use out into the code that calls it. In this case, into the main method. So at this point, you might say to me, "Well, that's great. All you've done there is made printDay simple, but you've made main worse because you've pushed those dependencies out into main." But look again at main. Actually, main already had those dependencies. In order to pass them in, it already depended on those things itself. So actually, main hasn't grown any new dependencies here. All that's happened is that printDay has lost them. printDay has become this standalone bit of code that does this really simple job and no longer needs to know what a print stream is, or a clock for that matter. It's based on concrete things. An instant is like a concrete concept. I don't know whether it's a concrete class. I think it is a concrete class. It doesn't know anything about print streams. I think it's better. So now printDay, as I said, needs to be renamed. All it does is converts instants to day names. Doesn't know how to ask the time. Doesn't know how to print things out. So here are my conclusions. Try and make most of your code low dependency. Not just injected dependencies, but actually doesn't have any dependencies, or has as few as possible. And in exchange, you're probably going to have some code that all that stuff gets pushed out into, and that's going to be your highly dependent code. And I'm starting to think that the way to think about that is the low dependency code is code that is responsible for being something. It represents some concept, like a way of translating times into strings, or like representing some value or concept. And then you've got some code which is doing stuff, and that's the harder to test stuff with more dependencies. Still testable, by the way, but you're going to experience more pain testing it. So try not to have too much code like that. And that's maybe part of my recipe for avoiding writing code that needs a dependency injection framework. And also, earlier on, reasons why using a dependency injection framework could make your life harder. I would really welcome your comments. I hope I've been fair, but I am obviously putting across the point of view. I'm really interested in your responses, especially if they're nice. If you enjoyed this video, there are loads more videos on my YouTube channel and also on my PeerTube channel. So like and subscribe and all that. If you like fun, play my game Rabbit Escape. If you want to find out more about my stuff, go to artificialworlds.net or my blog, artificialworlds.net/blog. You can follow me on Mastodon, which is like Twitter but with fewer haters. Or you can also follow me on Twitter. Have a look at artificialworlds.net for more ways to see what I'm up to and contact me. I'd love to hear from you. Hope you enjoyed it. See you next time.